Good morning, everyone, and welcome. We're so grateful you've chosen to spend part of your day with us for a thankful story about the Control Editor. As we head into the season of gratitude, we couldn't imagine a better moment to gather together and celebrate the tools, the technology, and the incredible community that help keep the ZOS environment running strong. Before we kick things off, just a few housekeeping notes to make sure today goes smooth and cozy. This session is being recorded. You'll receive an email early next week with a link to the full recording on YouTube. Feel free to rewatch, share with your team, or play it again while enjoying some leftover pumpkin pie. As well as we move through today's presentation, please use the Q&A panel anytime to drop in your questions, then type them in as they come to mind. We'll save that at the end to go through everything, but you don't have to wait to put them in. We'd also love for you to stay connected with us. You can follow us, New Era Software, on LinkedIn, Facebook, X, and Instagram to stay in the loop on all of our events, webinars, product updates, and releases. And don't forget to visit our YouTube channel, where you'll find recordings of every presentation, including today's. Before we begin, I want to quickly share something we're especially thankful for this season. If you haven't checked out Z Minds yet, that's a podcast proudly sponsored by New Era Software. Z Minds brings you inspiring conversations with thought leaders and innovators across the mainframe community. It's where we dig into the ideas shaping the future of the platform and spotlight the professionals who make that future possible. With all that said, it's time to jump into today's story. And now it's my pleasure to introduce our speaker and co-founder of New Era Software, Paul Robichaux.
Okay, thank you, Sammy, and welcome. As Sammy mentioned, this is a busy time of the year. Thanksgiving's just around the corner, and we're really pleased that you made the decision to come out and share part of your day with us. Listen, the takeaway point here is really summarized on this particular slide that I'm beginning with. The number one rule in system programming, which I have devoutly preached for almost 40 years now, is that as a system programmer, you always want to make sure you have a backup before you make a change. And if there's anything fundamental in the control editor that accomplishes that, is when you install it, it will immediately make a backup of both parmlib and proclib, and it will maintain that backup over time so that you're always assured, even if you might have forgotten to make a backup, that there is one that you can fall back to. But even though that safety net is there and will never fail you, the control editor AI is far more than that because it's able to allow you, as what we will refer to as a decision scientist, to make additional requests of it through a process called categories to add additional data sets that you believe are important in your environment that you want to have maintained as backups over time. In addition, it will track commands, operator commands that you feel are important, and it will provide you with alerts on messages that are being issued by the system that may indicate updates or may indicate problems of one kind or another. All of this is defined through an integrated development environment that allows you to build site-specific rules and to use those rules to manage the system in such a way that eventually it will provide you with an, excuse me, a set of reports and alerts and a way of navigating all of its data through what we refer to as an EDA or exploratory data analysis function. So sit back, enjoy it, but the takeaway point here is that we're going to build a safety net for you. And in doing so, we're going to enforce the number one rule of system programming, which is always to have a backup that you can fall back to. Now, like any AI, our AIs, including um, Valboot AI and IPL check AI, all follow a comparable model. The models themselves, that is the AIs, are attempting to solve some form of a complex problem. In the case of the control editor AI, the complex problem is how do we maintain a consistent, reliable, verifiable set of backups How do we track operator commands? How do we track messages? How do we do all of those things that allow us to have a broad view of the functionality of a specific instance of ZOS? That's a real world problem. That's a complex problem that requires a data scientist who understands ZOS in and out and can program the rules that are necessary for the AI to actually integrate and interface with ZOS in such a way that it can capture and manage that. That training that goes on, that supervised and in some cases unsupervised training, leads to a model that has been built on basic techniques of machine learning. But on the other side, there has to be someone, in this case you, who can act as the decision scientist. That is, that, okay, that's all well and good, and let me see what the output looks like and see whether or not this thing actually did something smart. That person, you, have to be in a position to say, yes, I understand what this is doing. I understand these backups. I understand the capture of these commands. I understand the capture and reporting of these messages. But in addition to the ones that we have, I'd like to add some more. And so you get to play a role as well in programming and training the model to do things that are specific to your environment. So at the end of the day, what we have here are two broad categories of functionality. On one hand, we have an agentic AI model, that is one that's acting as an agent for you doing your work. It's based on a rule-based reasoning engine. It interacts directly with ZOS, and it focuses on your specifics. The model itself is essentially made up of two sets of rules. Those which allow it to interact with ZOS, we create those, and those that you specifically say, I want you to do these things for me. Those are your specifics. Included with the model or with the AI is an integrated development environment. And that environment is going to shield you from the underlying syntax, that is, those specific commands that are given to the model to get it to do what you want it to do. You could, if you wanted to, learn that syntax and use it directly, but we would recommend that you instead use it through the IDE. The IDE is also going to provide you with a way of exploring the data that comes from it, building reports and sending them at intervals that you choose or as alerts. And importantly, what this will do is assure a level of consistency in the application of TCE AI, not only for yourself and for your other teammates, but also for accelerating the onboarding and training of new individuals that may come into your organization. So there's broad level of control here. There's broad level of specifics that need to be identified, and you are going to play a very important role in that regard. So here's a broad overview. First, up at the top, we have the 5 different categories of information, if you would, of domains of content that the AI is capable of being able to manage. So data sets, libraries, HFS files, commands, and messages. And once it's installed, it's constantly interacting with ZOS to determine whether or not it has any specific instructions from you to do some specific task relative to those 5 domains. Immediately on installation, it will take an action on your behalf, which will be to back up parmlib, proclib, and maintain those backups over time so that you're assured that that rule number 1, always have a backup before you make a change, is in place and is constantly there, giving you a verifiable backup that you can fall back to if you need to. Of course, you're going to play a role as a decision scientist, and you're going to train and refine and retrain the model over time, building a set of event rules. And those event rules will be in a registry, and that registry will interact with the underlying TCE AI to do essentially three things. Number one, when you define an event to it, whether it's a data set or a file or a command or a message, and it captures it, it's going to store it in a journal. Now, the good thing about this process is it doesn't require any modifications to the system, doesn't require any exits to your system, and doesn't require SMF records in order for it to function. So it's essentially autonomous. It doesn't require those extra services in order for it to be able to perform its function. In addition to the journal, that is the recording of those events, it's also going to issue real-time alerts if you tell it to do so. And it's also going to enforce controls over access to data sets, access to commands if you tell it to. And you can use it to the extent possible for implementing zero trust. That is, in those instances where you think there may have been some level of over-permitting, you can use TCE AI to manage access to members in data sets that goes beyond the access control as provided by RACF, ACF2, and Top Secret. So in a sense, what you're going to be doing is what's often referred to as ML ops. That is, you're going to be performing a task that allows for you to do machine learning. That is, you are going to make the machine do what you want it to do. And that interaction with the model is critical to the understanding of how this guy is going to work to enforce your specifics. Now, from a perspective of the integrated development environment that the AI will use in order to give you access to these tools, it's a 3270 environment, and it's accessible from the TSO command line anywhere inside of a TSO environment. So this is what it looks like. And with that said, what I'm going to do is I'm going to shut this down. And if there are any questions or issues at this point that you'd like me to address, I'm happy to do it while I'm making this transition. Okay, make this big enough here. Okay, so here's our interface. And as I mentioned, we got here from the TSO command line. And so here I am in TSO on the basic command line. And again, this can be accessed from any place in TSO. You could be in SDSF, or you could be in the log, or you could be in 3.4, or you could be essentially anywhere within the system. You don't need to create another environment, although there is another full function environment that requires a VTAM application that will provide you with the same functionality, but additional access to functions within the integrity controls environment. So at the command line, all we do is type TSO, dollar, command line interface, comma, asterisk, CEIDE, Integrated Development Environment. And here we are. So now on the left-hand side, we see the 5 areas that we're going to focus on: data sets, libraries, Unix files, commands, and messages. On the right-hand side, we see some additional functionality that is available to us in the form of ad hoc queries that you can make directly into the system at any point in time against the journal, and guardrails, critically important for the functionality here to protect the, the model, if you would, from unauthorized use or access. Now, right now, the guardrails are down, and so you can see down at the bottom, it says guardrails are currently inactive. But this is how easy this is. We just put the cursor under that, and now these guardrails are back up again. And the way these guardrails work is in conjunction with a facility class profile that protects admins, users, and auditors at different levels and directs them to specific functions inside of, TCE AI. Now I'll turn them back off again because some of my colleagues like to come in here and function as well. But you can see right now I'm the only individual that's actually permitted. Now there are other guardrails here. We call those padlocks, and those specifically protect access to data sets, libraries, Unix files, commands, and messages. And you can see right now, they're all turned on, but at the global level, the padlock control mode, that is the overarching padlock control, is off, but I can turn that on. So now it's in deny mode. So in those instances, when this global control is on and the individual padlocks are on, then access to specific data sets, libraries, Unix files, commands would be denied. Or it could be warned. That is, that you would get a warning message and say, well, hold on here a second. Do you really realize what it is you're doing? So we'll go ahead and turn that off now for this moment. So I'm going to go ahead and select one of these. I'm going to select data sets. We just put the cursor in the field that says data set and press enter, much like a web page or something like that. And we'll display an interface. Now, this is a common look for managing the specific functions of TCE AI. What we're in now is a panel that allows us to describe what are referred to as categories. A category is a grouping under a specific name that contains data sets. So for example, the first one up here at the top was actually automatically created by TCE AI when it was first installed. So if I put the cursor under System Parmlab and press enter, we'll see the 4 data sets that it actually picked up and recorded backups of them in the control journal that I mentioned earlier. And if in turn I put the cursor under sys1 parmlib and press enter, I'll actually see what's in the journal. That is all those specific backups that are in here at this particular point in time. And then if I put a list versions, it'll list the 3 versions of that particular data set that are now in the journal. And if I select edit, it'll actually allow me to begin the process of doing my work. So once I set up a set of libraries, the information that is in those libraries can then be managed through this interface, much in the same way that you might use some sort of code development library set of one kind or another. So this is sort of helping to perhaps displace other products, perhaps implement some other mechanisms for actually maintaining the system. Now, if I can do this, we're in edit. We could pick another member here. So this was a specific member, of course. Oops, list, edit. Oh, okay, so I just added a line here. I just copied this first line, 05, again to the area below it. Now, when I hit PF3 to back out, what it's going to do is display a descriptor. And what this descriptor is telling me is that in order for me to complete this update, I'm going to have to provide it with some additional information. So what this means is that not only did we take that original backup, not only are we tracking the changes that are being made to that backup, this is an instance of a change being made, but we're also requesting additional information about what in fact was changed. So now if I say, no, I don't want to do that, I can just can out of this and perhaps go back and do it again. Now this time, you notice my change didn't take place. Remember, I copied this line and there would have been a blank line here if I had done this the way that was anticipated. But let me do something a little different here. Let me copy this line and put it before, and there it is. And then I'm going to add a bit of text on it. And now I'm going to hit PF3. And now I'm going to come here and then say, okay, well, what are you doing? Well, okay, well, here's some additional information. Now, if you choose to, you can select other descriptor panels. I think there are 10 of them that we offer as working models that you can use directly or you can modify easily. And there can be all kinds of additional fields and places for entering data here down below. This is the simplest of all we use for demos, but more complex descriptor panels are available, and you can design them as you see fit to fit your specific circumstance. Now, if I say, okay, I'm good with that, and I hit PF3, now I'm in a panel that says, okay, you filled out the descriptor. Is that really what you wanted to do? And is the edit what you wanted to make? If the answer is yes, then here's what's happened. At the very onset of this process, TCE AI took a copy of the member that we were about to edit. Now it has the edited member. So it knows that you've made a change. And so you could still can out at this point if you wanted to. But if you say, yes, I want to go forward, then what it's going to do is it's going to write the full member and the change detail into the control journal so that you have an ongoing provenance of that member over time. So what we're doing in essence is creating another version. Said yes. Now we're back out again. Okay. So now in that journal, we have a copy of what it is that we just did. Now there's some time that's required in order for things to get up to speed again, some changes that'll have to be made in terms of activation, but we'll come back to that in just a moment. The update is instantaneous, but the display in the panel, I guess, is what I'm trying to say, is not necessarily instantaneous. Now, as we go forward, if we want to, we could take another path. We cursored under System Parmlab and pressed Enter to get where we were, and we looked at those 4 data sets. But if we put an S here for control, okay, so this is, we're going to make a change, and you have to have special privileges to do this. You could be just a regular user and do what I just did, but if you're going to make a change to the model itself, like this, then you're going to have some special capability. Now, here's what we see here. These are the four data sets that are in that grouping that's referred to as a category of system parmlog, the one that we made automatically when you first install TCE. Now what we can do, if we choose to, we could delete something from this grouping if we chose to do it, or we could add additional data sets to the grouping if we chose to do it. So if we want to add one, we just simply say add, type in the name of the data set. If we want the specifics of a data set that's on a specific volume, that's on a specific system, we can provide that information as well. So right now, in the way in which the panel is set up and the way in which we initially created this System Parm Live group, we said, listen, we don't care where Sys1 Parm Live resides. We don't care what volume it's on. We don't care what system it's on, because the control editor is a broad-based environment built inside of ZOS that understands the complexity of things like a sysplex, or the complexity of things being modified from different locations within that sysplex environment. And so the backups that you find will be backups that have been created as a result of an initialization of the system, but from that point forward, any changes to them could come from many different directions, and this guy will capture essentially all of that. The same thing basically holds true for other things. You can see here, I actually have my TCE AI models out here. They exist in two data sets, Lib and Lib2. And again, if I want to do some work, I can just essentially click on one of these guys. Here are the backups that are out there. Here's the number of versions that are out here. I can list them, and then I can select them, and I could essentially go to work on them. So I could do all that right here without having to use some other development environment for doing my work. If, for example, I was also doing work on this module NSYM PRX, and I was doing it outside of the control editor. Let's say I was doing it with a specific editor on my laptop, and I moved the file into this data set, then at an interval of approximately an hour, the changes that I made would be detected, and they, in fact, would be written to the journal and then be available as a backup if I needed that at some future point in time. Quite flexible, quite good in the sense that it's always looking out and protecting those backups and making sure that you have one that is verifiable for your work. Of course, there's also the training for TCE AI out here. And I'll just show you what the interface is giving you an opportunity to, let's say, work around. One of the critical data sets in the training information is this one, NSECTL. That's the one that contains the training information for capturing data sets. If we select that, and then we attempt to edit it, you can see how many different versions of that exist at this point in time. You'll see some of the complexity of the syntax that's used in order to capture the information that we're using. So here, for example, is the syntax that's necessary in order to set up the TCE AI models. So we have to set up the category, we have to give it a name, we have to give it a descriptor. What type is it? It's an edit type. Are the controls on? That is, those controls that said, hey, you know what you're doing, you want to make sure. Okay, validate it. Are changes on? That is, when we run detected changes on an hourly basis, will they get picked up? All that's done automatically. And then the data sets are defined. And so within this category, category begins and category ends, the data sets are there. If you wanted to, you could come directly into this and add another data set. You could just copy this format and say, GS, give me another data set. And that would update, and the IDE would update accordingly so that the next time you came into TCE AI, you wouldn't have two data sets any longer. You would actually have three. So I'm just backing out here. We can do the same thing with Unix files. Same kind of panel interface, same basic structure, except in this case, we're using USS directories. Here's one that critical to me, containing some pageant and GSKK-man or GSKK-lib path, if you would, to various databases. Same basic approach. Let's list what we have. And even though this is a Unix file, we can edit it directly, make changes to it. They'll all be captured. They'll be put in the journal, be there for available backups. I haven't spent any time explaining these other commands across the bottom here. Let me just spend a moment on this. In addition to the data sets themselves and the establishment of the categories, we can establish what are referred to as prompts. So a prompt is essentially a guardrail. It's either on or off, and you can establish them on a category by category basis. And so you can see right now there is no password or prompts associated with this particular category. In addition, a higher level of control called a padlock can actually be put in place. We turn those on and then off on that primary panel. We can set this up for what we refer to as multi-factor edit functionality. That is where we are challenging the user to provide us with additional information before we allow them to edit a specific component, specific data set or file. Using this multi-factor edit can get you to the point where you can have a zero trust environment for some of your members or data sets that is clearly an extension beyond what is available with RACF, ACF2, and Top Secret. You can establish notifications on a category by category basis. You can establish what's referred to as an on-edit function. On-edit is kind of an interesting function. It's quite unique in the sense that if you attempt an edit of a component that is defined within one of our categories, whether it's a data set or a Unix file, and the TCE AI discovers that that particular file or data set or member does not match with the last recorded entry in the journal, it will pop up a a warning that says, hey, this is not the last one. This got changed somewhere else, and it hasn't been yet recorded in the journal. Do you want to proceed Yes or no? If you want to proceed, then it will allow you to do so, making additional copies of that so that there is a an audit trail of the original attempted member that you were trying to edit and the one that resulted from your edit work. Descriptors, excuse me. Descriptors can be defined to allow, you can see here the current descriptor that's being used in this category is a default one, but there are many other descriptors that are available as well. So these are the ones that are currently available in this system, and any of them are potentially usable within a specific category. So quite flexible. So one of the functions of the IDE, that is this tool that we're in right now, is to shield you from that syntax. So for example, if we were looking at commands like the set command, we would see a list of all of the set commands. And if we said, okay, well, we want those kind of commands that are what are often referred to as the single sets, that is set parm, as opposed to set space parm, we call those as the double set. And I put the cursor under set prog. Now I'm going to get all of the commands that are associated with set prog. So now, single set prog. And now what I have here are all of those various commands. Now, we can set them to be monitored, but we can also do additional work with them. For example, we can actually issue those commands and step you through each of the functions that's necessary for these commands to be activated or implemented. And some of them are quite complex. For example, link add is a complex command. We have to know what the name is going to be of the excuse me, of the linked list that we're adding it to. We need to know where we're copying it from. We need to know the data set. You need to know a lot of things, but you don't have to know the syntax of how to add it. You just have to know a bunch of things in order to make that possible. So again, shielding you from the underlying syntax that's necessary not only to capture and manage commands, but also to issue them. Okay. Messages is similar. I don't have any messages defined, but you would simply put the message here, you would click under it. You could extend the message text to be not only the message ID, but also the text that's in the message itself. So lots of flexibility there. All right. So I think you probably have a general enough idea here. We would love to see your interest in this and give you a more in-depth demonstration or actually begin a proof of concept within your own organization so that you can see how this would fit within your specifics and give you an opportunity to actually act as that data, uh, excuse me, actually as the scientist who is going to be responsible for making decisions about what it is that's actually going to be programmed as a companion to our underlying model. All right, so let me stop sharing this if I can find my button. Go back to this. And essentially wrap this up. So here's some takeaway points. Now, the major takeaway point is always have a backup, always have a reliable, verifiable backup, particularly things like ParmLab and ProcLab. But important to note here is that this system does not require any modifications or hooks in order for it to do its job. It simply drops in, makes that initial backup, turns the IDE over to you, and you begin to play the role as the decision scientist, programming it, training it to do your specifics. It obviously ensures a recovery point. It offers real-time monitoring, automates compliance with policies, implementation all the way to zero trust, will actually make recommendations on how to manage the journals so as to reduce event storage. There's no need for SMF records, and it aids in rapid onboarding of new system programming staff. And importantly, not listed here, is it provides a level of consistency in understanding the controls that are in place by simply going to a single focal point to see those controls, understand them, and modify them if necessary. I wanted to tell you that we're going to be back on December 11th. You can see my little cartwheel here for another webcast. I hope you'll sign up for that. It's going to deal with the IBM Health Checker for ZOS and using it in conjunction with the agentic IPL Check AI. This is an environment that will allow you to totally automate the relationship between IPL Check AI and the health checker to allow the health checker to actually manage the functionality of IPL Check AI on an ongoing basis. We will be discussing a number of different AIs that we have that position themselves along the system programming workflow, as we like to refer to it. TCE AI is the first. Always have that immutable backup. Valboot AI is the second, which can assist you in creating a secure boot environment for your ZOS environment itself. And of course, IPL Check AI. Takeaway point here for TCE AI, and hope that you will probably, I know you will want to, but I hope you'll get the authority to do it, is to come back for an in-depth client briefing with my colleague, Glenn Bagsby, and work with Sammy to arrange for a no-charge proof of concept in your organization. Okay, so that's it from me, Sammy. I'm thankful for the time that we got to spend here and wonder if we have any questions at this point.
Thank you, Paul. I don't see any open questions at the moment. I'll give it a minute. If anybody does have any questions, please feel free to put them into the Q&A now. Otherwise, we will wrap this up momentarily.
Okay.
All right. I don't see anything coming in. That being said, if anyone does have any additional questions they didn't want to or weren't able to ask during this presentation, or something comes to mind after we close this out, I will be contacting everyone via email, so please feel free to get a hold of us there and reply to me, or you can always just give us a call at New Era Software. We're happy to take your call anytime. I just want to thank you, Paul, and thank all of our attendees for joining us today as we wrap up a thankful story about the control editor. We truly appreciate you spending part of your day with us and part of this season of gratitude. We hope today's session gave you new insights, ideas, and a deeper understanding of how TCE AI can support your ZOS environment with confidence, clarity, and control. A few reminders before we send you off to the rest of your day. You will be receiving a link via email to the full recording, if not by the end of the week this week, early next week. So keep an eye on your inbox. If you didn't get a chance to ask the questions, as I said, you can reply to me there. Don't forget to follow New Era on LinkedIn, Facebook, X, and Instagram so you can stay connected with us all year round, and be aware before anyone else of all of our webinars including today, which you will see on there as well. And since Thanksgiving's just around the corner, we just want to say how grateful we are for this amazing community. Your collaboration, curiosity, dedication to the mainframe world are what makes events like these possible and meaningful. So thank you so much. On behalf of all of us at New Era Software, thank you again for being here and have a wonderful rest of your day.